3.7. I love the stuff that we just did in the task. I love using synthetic division and finding all the roots of a polynomial function. There's just something that is real satisfying with taking this complex problem, this enormous polynomial, and finding every x-intercept that it has, real and or imaginary. And hopefully, as you guys are working through this task, because this is a big part of this chapter now, we've slowly worked through analyzing a graph, finding domain and range intercepts, max and mins, intervals of increase and decrease, and into behavior, and we've been using that to create graphs, but those are just for ones that have really been factored for us. So how do I do all of this when I don't know the x-intercepts, when it's not factored? And it's just, I don't know, I just really like working through these. And I want you guys to have fun with the ready. In the ready, you are going to sketch a graph. So on a piece of binder paper, you're just going to make a quick rough sketch. That's all this is. And every single one of you could have a different graph. There is not one right answer to these. They should look similar, but you'll have them different, and it's okay. And you're not using numbers. You're not doing anything with that. Pay attention to the directions that they're giving you. So number one, a cubic function with 1, -0 that has a multiplicity of 2 and 1 positive 0. So you're going to have to look back at your definitions. I'm not doing any of these for you because I want you to really make an honest effort here. Look back at your definitions. Start with drawing out maybe, so I would draw a coordinate plane. Okay, this is how I would start. I would draw a coordinate plane. And I would say, okay, a cubic function. That's what the cubic function is supposed to look like. A -0. Great, here's a negative side. But its multiplicity is 2. So you'll want to look up the definition of multiplicity. What does it mean when its multiplicity is 2? Oh, odd crosses, even touches. So because the multiplicity is 2, that means it's just going to touch the 2. And then it has 1 positive. And so it's a cubic function, which means 3. Here the multiplicity is 2. That means there's only 1 multiplicity left. So there's your intercepts, your x-intercepts. Use the multiplicity in the shape of the cubic function to draw your graph. I'm not going to draw that one for you. In number 2, a quartic function with a negative leading coefficient. I crossed out a positive y-intercept and then 1 -0 double root. So think about what the double root means. That's the same as multiplicity. 1 positive 0 and 1 0 at the origin. So that's why I had to get rid of a positive y-intercept, because you have a 0 at the origin. That is the y-intercept. You can't have 2 y-intercepts here. It would not be a polynomial function. So that was a huge typo here. So don't pay attention to the positive y-intercept. Get rid of that. Number 3, a cubic function with 0 real roots. Guess what? That doesn't exist. You cannot draw that. I don't know if that's a typo or not, or if they drew that, or sorry, not drew that, but they wrote that wanting you guys to see if it exists or not. And in the past, I would have students that would draw this. They would draw their cubic, so it's not going to touch an axis. But what is this one going to do? This arrow is going to keep going. Oh, I just crossed the x-axis. Now I have a real root, a real 0. So number 3, you cannot do that one. Okay, don't worry about that. Actually, let's change that. Let's change the directions. Let's go with 1 real root. Okay, so draw it with 1 real root. And if you can't get that after what I just showed you, pause it, rewind it, watch it again. Number 4, a quartic function with 0 real roots, a positive leading coefficient, and a positive y-intercept. So have fun with those. Do the best you can. Compare your work with your classmates. Who knows, maybe you actually got it. But look at your definitions also, okay? So that's the ready. Now the set. This is where a lot of work is going to come in. And you are not going to be able to fit your work here. You are going to have to do your work on another piece of paper. And if you want graph paper, I have graph paper. Ask for graph paper. I'll probably have already asked you in class who wants graph paper. So find all linear factors. Sketch the graph, unless you see another method that allows for quicker graphing. If so, explain your method. Just factor it, you guys. This really is not that bad. And the reason I'm saying just go ahead and factor it is because I know it's coming up on your quizzes and your tests. You have to identify things. You have to identify the x-intercepts. You have to identify the y-intercepts. So make sure that you guys do go through and find the factors. So for example, in number 5, I would need to start by factoring out an x squared. They both have an x squared. So I'm left with x minus 5 equals 0. So I have x squared equals 0 and x minus 5 equals 0. So I get 0 and 5. So there's my x-intercepts. So now to make my graph, because this was an x cubed, I know it's going to be a cubic function that goes up because it was a positive. So I have 0 and I have 5. Okay. Multiplicity. This one has a multiplicity of 2. This one has a multiplicity of 1. Don't forget, the multiplicity is the exponent. Since this was an x squared, it had a multiplicity of 2. This one does not have an exponent. It has a multiplicity of 1. Odd crosses. Even touches. So I have to start down. I touch the 0. I go back down. And I go over and I cross the 5. So there is my cubic function. I do not want to see this, you guys. Okay, or a V here. And then this. You have to curve your graph. It's curving. It's a polynomial, smooth and continuous. And that's it. That's all you have to do here. Okay, so don't overthink these. And then again, you can check in Desmos. You are welcome to check in Desmos every time just to make sure you guys are doing this correctly. And I've watched some of you guys do this in class when you're working on classwork or homework when we have time. You're using Desmos. Please don't be afraid to use Desmos. It's there for you. Okay, so that's number 5. I do want to help you with number 8 just a little bit. Okay, I want to help you there. Because this one's hard to factor because you got 4 terms. And we haven't gone over how to go through and factor this. But I'm going to go over this now. Even though I'm given a hint about a root, I can use what is called factor by grouping. Okay, factor by grouping means I'm going to make 2 groups. So I have my first 2 terms and then my last 2 terms. I'm going to look at the first 2. They share an x squared. So I'm going to take out an x squared and I'm left with an x minus 2. Then I'm going to look at the second 2 terms and they share a 9. So I'm going to take out a positive 9 and I'm left with x minus 2. What you notice, or I hope you notice, is that now the parentheses are the exact same. So now I'm going to factor one more time and I'm going to factor out an x minus 2. So the x minus 2 is now outside the parentheses and I'm left with x squared plus 9. One of the things that just helps me remember factor by grouping is I just write the parentheses once and then what's left outside of the parentheses gets written together. Okay, so there's the outside, here is the inside. So those are my 2 factors. So I set each factor equal to 0. So my first intercept is 2. And then my second intercept, well, this is an x squared equals -9. And when I square root this, it's imaginary. So I don't have another root there. With this one, the x equals 2, the multiplicity is 1. Odd crosses. Whoops, I can't not spell the word cross. Odd crosses. So to create a quick graph of this, very quick. 1, 2. It's going to cross at the 2. It has to cross there. So to draw this, and when you're checking on Desmos, we're not looking for anything specific, but my y-intercept is -18. So down here, we'll say down here is -18. It's got to cross the y-axis. It's got to, actually that's a horrible looking graph. Let me fix this. There, that's more accurate. So here's the 2, and it's got to cross through the 2. So it starts up, it crosses, and then somewhere up here it's going to go back down and then back up. So if you check on Desmos, it's going to look something like that. It may not look exactly like that, but you're just making a rough sketch. Don't overthink these, okay? Don't make them more complicated than they are. And then they really are not that complicated, but you do have to be able to factor. Okay. That's it on those. That leaves you guys 6 and 7. So you need to do 6 and 7 on your own. Okay, in 9 through 12. 9 through 12. You are using the remainder theorem to determine if the following are roots to the given equation. If so, find the other roots and graph the equation. So once you find the roots, you're going to graph it like back here in 5 through 8. And then you can check on Desmos. To use the remainder theorem, the 1 goes in the house. And again, you're going to have to do this on extra paper, you guys. Can't be lazy and try and fit all this in here. I'm not going to give you credit. You're going to turn this in and I'm going to say, where's your work? You didn't do any. Go do it again. And now you're going to get zeros because you're probably not going to go do it again. So do the work the first time. So in the house, I put the 1. And then the coefficient of the x cubed, the coefficient of the x squared, the coefficient of the x, and the constant. I love synthetic division. It is so much fun. So I start by bringing down the first coefficient. I multiply, which gives me a 1. I add these, which is 6. I multiply, which gives me 6. I add these, which is 8. I multiply, which is 8. And I add those, which is 0. So that means yes, this is a root. Now, once I know that that's a root, actually, I don't want to factor yet. Let me write this. This would be, since that is a root, I take a root away. And don't forget, the roots go with the degree. So if my degree is 3, but now I found a root, I have to take one away. So now I'm at x squared plus 6x plus 8, which factors to x plus 4, x plus 2. So my other zeros are -4 and -2, and then the 1 that worked. So I would create, and all the multiplicities were 1, so I'd be at -4, -2, and 1. So they all would cross. Every single one of these would cross. And my y-intercept was -8, so I would say that that's -8. So rough sketches, guys. You're going to go through and you're going to do this for 10, 11, and 12. Don't forget to use placeholders, please, in the synthetic division. For example, on 11, I would put -3 in the house. My coefficient with x cubed is 1. There is no x squared, so you have to put a 0. And then I could put -19 and -30. Okay, and so be careful with that on 12 also. Don't forget to use your placeholders. Okay. Whew, we're almost done, guys. On the go, you can cross out the go. Don't worry about the go, because this is already a lot. So you're going to write the polynomial function in standard form when given the leading coefficient and the zeros. So the leading coefficient goes outside of the parentheses. The roots go inside and you change the signs. So I'll just set up 13, but you guys need to go through and finish it. So the 2 goes outside. The roots is 2, root 2, negative root 2. So it's x minus 2, x minus root 2, and x plus root 2. That is not a polynomial function in standard form. That's factored form. So to write it in standard form, you would need to multiply everything through. So I would start by multiplying the 2 to just the first parentheses, which gives me 2x minus 4. Then the factors that have the roots, multiply those together. You're going to FOIL them, or you can use the box. It's up to you. So I have x squared plus root 2x minus root 2x minus the square root of 4. Well, guess what happens here? They cancel. That's why you want to make sure you multiply the roots. So I get 2x minus 4. And then this is x squared minus, what's the square root of 4? 2. And then from there, you guys can multiply one more time. Okay, so you're going to distribute again. So you guys can finish that, and then you're going to go through and you're going to do the same thing with 14 and 15, but be careful on 14. Okay, these ones, those are beasts. Have fun multiplying those ones. I'll put them in parentheses for you. This would be negative 1 on the outside. Here's a root of 1, so it's x minus 1. Then it's x minus 1 plus root 3. X minus 1 minus root 3. So you're only needing to change the sign of the 1. Okay, that's all you need to do. And then multiply those first. You might want to use a box, guys, to keep your work organized. Or make sure you have a big enough piece of paper. Don't make mistakes. Take your time. Okay, it's not super, super difficult stuff. All right, that wraps up 3.7. You know where to find me if you need help. See you tomorrow.